everyone. Today I will be discussing the environmental and community social issues connected to the consumer 3D print in Memphis, Tennessee. This speech is to inform everyone about the current environmental and community social issues caused by consumer 3D printing in Memphis, Tennessee, including plastic waste, indoor emissions, and community exposure in schools and makerspace. Consumer 3D print creates plastic waste, microplastic pollution, and airborne emissions, and these issues directly affect Memphis communities that use 3D printers in educational, creative, and residential spaces. When a 3D printer finishes a project, the object looks clean and futuristic. But the leftover scraps, fumes, and particles tell a different story about the environmental impact behind technology. I reviewed recent scientific studies from reputable, unbiased sources that examine 3D print emissions in schools, sustainability challenges, and environmental risks associated with consumer printers. CDC NIOSH 2024, Sustainable Production and Consumption 2024, iScience 2025. Memphis schools, libraries, and makerspaces increasingly use desktop 3D printers, meaning these environmental and indoor air issues directly affect our community. I will explain these three current social issues connected to the consumer 3D printing: the rise of plastic waste and microplastics, indoor emissions released during printing, how these issues specifically affect Memphis institutes and residents. I will begin with the environmental waste created by consumer. A 2024 systematic review found that consumer 3D printing generates significant plastic waste, especially from failed prints and support structures, which often cannot be recycled through municipal systems. Sustainable Production and Consumption 2024. The review also notes that most consumer filaments, such as a PLA and ABS, frequently enter landfills where they contribute to long-term microplastic pollution. In Memphis, makerspaces and school labs produce large amounts of scrap filaments, typically enter household or institutional waste streams. Next, I will explain the airborne emissions produced during 3D printing. A 2024 CD NIOSH evaluation of 3D printing in school environments found measurable levels of volatile organic compounds and ultrafine particles during printing activities. The study recommends ventilation improvements and exposure control strategies to reduce risk for students and staff. These emissions are especially relevant in Memphis classrooms and makerspaces where multiple printers may operate simultaneously. Finally, I will connect these issues directly to Memphis communities. A 2025 iScience article explains that 3D print emissions can reach levels comparable to urban pollution sources depending on filament type and ventilation. Memphis schools and community centers that use 3D printers may experience elevated indoor particle levels, especially in enclosed or older buildings with limited ventilation. Local makerspaces and small businesses generate plastic waste that often enters regular trash streams, contributing to Memphis existing waste management challenges. I will now summarize the key points we've discussed. In conclusion, the environmental and the community impacts of consumer 3D printing are becoming more visible in Memphis. Consumer 3D printing contributes to plastic waste and microplastic pollution. Desktop printers release ultrafine particles and volatile compounds into indoor air. These issues directly affect Memphis schools, makerspace, and households. Understanding these facts helps Memphis residents and institutions recognize the environmental footprint of 3D printing and documented risks associated with issues. 3D printers give us creative power, but they also leave behind plastic and particles, reminding us that even innovative technology has an environmental story. Thank you.